Welcome to Section 7.1, Ratios and Proportions for Geometry. Let's start by talking about the definition. A ratio is a comparison of two numbers by division. A ratio can be written in three ways. You will see it as A colon B, A over B, or A to B. Either way, all three ways are read as A to B. An extended ratio is a comparison of three or more numbers. You had an extended ratio on your Think and Discuss from last chapter, and we'll go ahead and practice an extended ratio this time as well. For an example, if I say that the angle measures in a triangle are in a ratio of 1 to 2 to 3, that means that one angle this angle right here is twice as large as the first angle, and the last angle is 3 times as large as the first angle. So in order to solve this ratio, I would take 1x plus 2x plus 3x. And of course we know that if we're adding all three angles in a triangle, the sum is 180. Okay, let's try an example. It says example 1, simplify the ratio 3 yards to 6 feet. So I want to know, how does 3 yards compare to 6 feet? Well, you need to remember that 3 feet equals 1 yard. And you need to put this ratio right here all in the same units. It doesn't matter if you want to convert it to yards or if you want to convert it to feet. I'm going to go ahead and put it in yards, I believe. Okay, so if I know that 3 feet is 1 yard, I don't need to change this one, the numerator, 3 yards, because that's already in yards. But I need to change my denominator, 6 feet. So if I want to say 6 feet, how many yards is that? Well, 3 feet is 1 yard, then 6 feet has to be 2 yards. So the ratio 3 yards to 6 feet is really a 3 to 2 ratio. And we're done. Example 2. The ratio of the side lengths of a triangle is 4 to 7 to 5, and its perimeter is 96 centimeters. We want to know what is the length of the shortest side. So the first thing I'm going to do is draw some random triangle. I'm going to mark the shortest side 4x, the next one 5x, and then the longest 7x. I know that each of the sides, because the ratio is 4 to 7 to 5, all have a common factor. So whatever that factor is, one side is going to be 4 times that factor, the next side is going to be 5 times that common factor, and the last side, the longest, is going to be 7 times that common factor. It also tells us that the perimeter of the triangle is 96 centimeters. And if you find perimeter, in order to find perimeter, you must add all three sides. So that's going to be 4x plus 5x plus 7x equals 96. Well, when I add the left-hand side, 4 plus 5 is 9x plus 7x, I get 16x equals 96. So simplifying, dividing both sides by 16 basically, you end up with a common factor of 6. What that means is that each of these sides is multiplied by 6. Now the question says, what is the length of the shortest side? Well, the shortest side is that side that has a factor of 4x. So in order to find the length, I just take 4 times 6. And the length is going to be 24 centimeters. And we're done. Okay, now we're going to start talking about proportions. And a proportion is related to a ratio. In fact, the definition is an equation of two ratios. So for instance, if I have a ratio of A to B, and I set that equal to the ratio of C to D, I have now created a proportion. Now there are certain spots in a proportion that we need to talk about, and they have names. So the very first numerator, I'm just going to highlight it again, which is A, and the last denominator, which is D, the numbers or the values that are in those spots are called extremes. Then that means the values in the first denominator, the B, and the second numerator, those are called the means. And if you, when you have a proportion, if you're going to solve for it, you always multiply the extremes together. The product of the extremes will equal the product of the means. And that's what we use to solve a proportion. Okay, so now let's start talking about some properties. And in fact, this first one, the cross product property, we just mentioned on the previous slide. It says the product of the extremes equals the product of the means. So what that looks like, if I have a ratio of 6 to 9, and I'm comparing that to the ratio of 2 to 3. Now I'm not solving for anything because I don't have a variable, but if I multiply the extremes together, which are the 6 and the 3, and I multiply the means, which are the 9 and the 2, they should equal, or they should have the same product. And they do, because 6 times 3 is 18, and 9 times 2 is 18. Okay, the next product is the reciprocal property. It says if two ratios are equal, then their reciprocals are also equal. So using 6 to 9 equals 2 to 3, let's look at the first ratio, 6 over 9. Its reciprocal is 9 over 6. That should be equal to the reciprocal of the second ratio, which is 3 over 2. And in order to check that, you would do the cross product property. Is 9 times 2 equal to 6 times 3? Why, yes it is. So this property works as well. Okay, so now we're going to start practicing some proportions. Example 1 says to solve this proportion. We have 7 over x equals 56 over 72. In order to solve, I'm going to use a cross product property. I multiply my extremes together, 7 times 72, and that should equal the product of my means, x times 56. Well, 7 times 72 is 504, and this is just equal to 56x. So now I divide both sides by 56, and I end up with x equaling 9. So I have solved for it. Example 1b, it also says to solve again. But this time I have z minus 4 in the numerator over 5 is equal to 20 over 4. So I'm still using the cross product property here. But I want to make sure I put parentheses around my numerator because I have an operation going on. This is going to be z minus 4 times 4. That's going to equal 5 times 20. Alright, well the left-hand side may look familiar. You're going to have to use the distributive property and take 4 times z and then 4 times negative 4. You get negative 16. 5 times 20, is 100. And now I just solve for, like I would any other linear equation. We're going to add 16 to both sides. So I have 4z equals 116. And then I divide both sides by 4. And z equals 29. The last example says Marta is making a scale drawing of her bedroom. Her rectangular room is 12.5 feet wide and 15 feet long. On the scale drawing, the width of her room is 5 inches, and we want to find the length. Alright, this is a good problem. You want to use pictures to help you solve. So this is a scale drawing of her bedroom. And this is going to represent her actual bedroom. Do I know any of the dimensions? It says her rectangular room is 12.5 feet wide and 15 feet long. It says the scale drawing, the width of her room is 5 inches. And we want to find the length. Okay, so let's set up a proportion. You can compare length to width, or you can do length to length. It does not really matter. I'm going to keep it as length to width. So I want to know that the ratio for her scale drawing, L to 5, will give the same ratio as her actual bedroom, 15 to 12.5. So we compared length to width and length to width. Okay? All right, now I want you to go ahead and finish solving example 2. We have the proportion set up, so you just need to solve for L. And then show me when you get to class in the morning. However, do not forget that length, you have units with length, so put your units in. Good luck.